Shall we start? Okay, hello everyone. Hi. Hi, all of you. Okay. Officially, this is our first class. This is our first week. Last week was it was an introduction. I introduced some common sense of the microwave engineering, and I also introduced this class, the microwave engineering. What will you learn in the future in this class? Okay, and how I design this course. Okay, I hope all of you can follow my English. Even English this is not my native language, but I try my best. Maybe I can slow down. So, can all of you follow my speed? Is that okay? Is that okay? If you got some problem, you are very welcome to raise your hand and tell me your problem, and I will try my best to help, to assist you to pass this class, okay? And before this class, I passed a paper, an exam, or you call them an activity to each of you. Try to answer all the questions and return this paper after the class. Then I can understand how much you understand. You can absorb my material in this class, okay? Try your best to answer a question. No hesitate, no pressure. Don't think about how many points you will give me. Okay, I already give you the rules last week. I already told you the rules. If you want to pass the class, you come to the class maybe more than 15 times, you get 15 points, right? Except that we will have the you are in class, and when you raise your hand, you answer my question, or maybe you write down the answer, you return the paper to me, and I see, you are a good student, and I will give you some more extra time, okay? Okay, to make you easier to pass the class. Are we good? Okay? Okay? You understand? Alright. So let's start from what we talk about scalar and vector in the end of the last class. Okay. Before we start, I want all of you to flip your paper, your exam flip. Okay. Write down an example of scalar and write down an example of the vector. Okay, I want to see how much you understand about scalar and the vector at the beginning. Please do that. It is not time to read your textbook yet. Hello? Not yet textbook. Please use your pen. Flip your paper. Write down, flip. Use the white part. Write down the answer. On the back, not on this side. I want to write down the answer. Yes, you are doing good. Yes. I want you to write down an example. You don't need to expand. What is that? Write down an example. You don't need Chinese, right? Use your mathematics. Use your algebras. Okay. Write down an example of scalar. What is scalar? And an example of a vector on the back of your paper. Let me see how much you understand vector and scalar. Just write down an example. Any. You don't need to read yet. Right? Okay. You already did? Okay. Okay. No, understand? Did you pass away last week? You didn't get scalar. Do you know what's a scalar in Chinese? Do you know that? You forgot. Okay. Vector. Okay. Can anyone help? What is scalar in Chinese? Yes. Vector? Okay, very good. Okay, so what is scalar and what is vector? You just write down any example to explain, oh, you know that is vector, you know that is scalar, okay? Close. But you need to change a little bit. Yeah, you don't know what is scalar, what is vector? I want example. Example. Show me an example. Do you know what's that? Example. Example. I want an example, not what you can use for that. An example. Try to give me an example. Okay, you can copy. If you don't know the answer, what you should write. You don't think about it. Oh, I want to get a point. No. I won't take your point away. I will give you a point if you give the right answer. Okay, it's a different thing. It's not a punishment if you don't understand. It's fine. You don't understand means I haven't teach you good yet, right? I'm trying my best to tell you, to communicate with you. So you need to understand what I am asking for. Okay. If you have a question, you don't know what is the example of a scalar, and you don't know what is the example of vector, turn back to your question. Okay, pick some part of that and write down. Okay, you think, okay, this is a vector, and oh, this is a scalar. Write it down. Okay, easy, right? Just copy my question. Copy some example from the question and as your answer. Okay? So, what is scalar? Scalar means maybe you have some number. Okay, for example, you write down like a 2, it is a scalar. You have some number, okay? And what is a vector? For example, I have a very easy example. 2x. You need vector x. 2 times, this is 2 times you need vector x. This is the example of vector. This is the example of scalar. Okay. More examples. Some students, you give me more complicated algebra. The example with algebra. What's that? Maybe you will say, how about 2x? This x has a head on it. So this x is the algebra, this is the unknown. So what is this? Is this a vector or scalar? This is scalar. Can you give me another example of maybe an unknown vector? A functional vector, maybe 2yx. Okay? This is a scalar, this is a vector. Okay? So, here we have 2 examples of scalar and the 2 examples of vectors. Okay? Okay. So, how do we call them? How do we call them? If you want to give them a name, maybe you can call that, oh, I will call you A. or maybe I will call you f equals to 2. The function f equals to 2 is a constant, okay? This is an example of function which has a form scalar, has a scalar form, okay? Or also we will call that f equals to 2x, because this is not a constant. The answer of f will change according to different x, right? So we can write down like it is a function f of x. They are examples of scalar. Okay, then you can also write down x, but it doesn't mean anything because you don't have x here, right? Okay, this is an example of scalar. More, because we know a lot about scalar. Scalar are usually we knew before, right? In this class, we are talking about electric field, magnetic field. Those are new stuff. You need to consider about direction. So you need to have a new notation, vector. So for example, maybe I will call this is something, and then maybe I will call this A. If you want to call an unknown, you want to give a name for the unknown, and the name of the unknown, it is a vector. You need to put the arrow here. Okay? Okay. You cannot just say fx equals to 2x, the unit vector. No. Okay, this is a rule. So if you see the unknown like this form, this is a scalar. If you know the unknown here, this is a vector. Okay, and also you can say A, and this is the function of y. Okay, you should understand this before you answer my question, because those are the rules maybe you don't know before. Okay, can we continue? Okay, everyone raise your hands. Raise your hands. Everyone raise your hands. Okay, if you totally understand, put your hands down. If you have some hesitate, something you have a question, you should ask now, or I will continue. Okay, okay. So if everyone okay, let me continue. Okay. Okay. So this is the first question you write down on the back, right? Please show us some examples about scalar function. So the scalar function is, what is a scalar? It is here. Okay? This is a scalar for the first question. Okay? You can write down f of x, y, z. We use x and y and z as their variants. Then you can change x, you can change y, and you can change z, and you got a result from that. So this is a scalar function for the first part. So this is your first question. Okay? And for the second, show me example of vector. This is more complicated, and it is complete. You have all the x, all the vector x, all the vector y, and all the vector z. Okay? Understand? Now, if everyone can understand, we can start for the next part. Okay, question number 3. Draw this vector. Maybe let me simplify this question to, I don't use 2, I use 1, okay? Okay. Draw this your answer sheet. Now, draw it. What is this? Draw. Do you know draw? 画. 画画. Draw this. Well, this is question number 3. Try to draw it. And let me see your answer. Guess what it is. This is very important, and this is a basic knowledge of the electromagnetic. Try to draw. Fun, huh? No? We are trying to, I try to explain the definition of the field. We need to totally understand the reason, and we can continue, we can start the book. If you don't understand the basic, you don't know what is a vector, you cannot start. Okay? As my experience, this is the most important part. Right? If you don't know a plus, minus, you don't know how to do the math, right? You don't know the definition. This is the definition. What is the unit? So, I think most of you think, I know vector. It's a direction, right? Okay. Right. Draw down this. I think the blue example, this is the easiest question for the vector, right? That is the easiest, right? Okay, let me see your paper. It is possible that no one answer. No one get right. It is possible. Because you don't know. You think you know, but you don't know. Show me. I haven't seen anyone get the right answer yet. No. Everyone get wrong. Show me. No. No, even you didn't get right. No. You are correct partially. It's not the correct right answer. Show me. You didn't draw. Right? See? Everyone think you don't even have the first question. How can I give you the extra point for intendment? Try. If you don't understand English, maybe I try to speed slower. You don't get it too fast. Okay. Maybe you are allowed to use Chinese to maybe show it or okay. I want to try to help you to pass, but you also need to work harder. Okay? No, nobody get right. Nobody get right. Nobody get right. No one. Maybe I have an answer for this question. Let's see that, okay? Okay, no one get it right. Try to plot these 3 examples. I just give you first one, right? I just ask you first one, but if you understand the first one, then you are also good for the second one, the third one, right? But nobody get it right for the first question. So the answer of the first question is that big surprise. And this is one of the very key points to understand vector. For this example, the example I asked you, do you know where it is? No. No. Why? I don't have the unknown x, I don't have the unknown y, and I don't have the unknown z. So, everywhere in this space has one unit vector direction going to x direction. I'm not talking about just one point. For the vector, we are talking about a rule. It is a rule. You can put your unknown x, y, z in your function, and then you put every position. They will have different answer for some case, but for this case, every position has 1 to x. Okay? For this question, it is 1 to y direction. So first of all, you need to define the x, y, z, right? For this box, x is this direction, y is this direction, and z is this direction. So for this case, you need to have something. You have the every vector goes to x anywhere. Okay? For any position, it's a 1 to x direction. So your vector at a distance, you need to show me or maybe write down something to explain that they're everywhere, not only one vector, not only one arrow. Okay? Okay. Question number 2. How about? Okay, let's put y. Let's make it more complicated. Draw it. Draw it. Okay. When you start to answer my question, you are thinking. You are not just listening. That's very important. I want you to think. Not just answer. Not just listen. You need to think. Think about why, if this is the answer for A, vector A equals to the unit vector of x. What is the vector A equals to y x hat? Draw, please, draw. Yes, it takes time to think, and you will know how complicated we are going to discuss. This is the basic. Close, but you only explain the direction. You need to also explain how big it is, the magnitude. Do you know magnitude? Magnitude means 大小. Yes, you need to talk about not only direction, but also the magnitude. Draw draw it. If you have a longer arrow, it's larger, okay? And the direction and the position, you need to put everything together to draw it. Think about that, how scientists described our electric field and the magnetic field. How scientists trying to describe. We need to understand why. And this is the only way. There's no easy way. If you want to understand electric field, you need to use this notation, this unknown. Think about it. You should also think about it. I give you some time to think. It's very important to think. In this class, remember is not the most important part. To understand is more important. Because you have everything in this book. You need to understand what they are going to tell you. Okay? I'm here to help you to understand what they are going to tell you. I know the reason why. This is outside this book is more important. Okay? Even in Chinese, you don't get it. So language is not the most important problem. It's y, x, right? You have 2. It's not 2. It's yx. Okay, just yx. Yeah, but you don't have a different depths. Do you think about it? You thinking? You need more time? Or you are waiting for an answer? Okay, it's fine. It's better than I just tell you the answer. You won't get anything. You think, and yes, I think you are the closest. You are the closest. Okay, you're getting better. You have a better. Okay, but a little bit change. It's better. Okay. You need to see the answer. Okay, think about that. Okay, I think the show is the closest, but out of you need to think about. See, let's see the answer. Okay, what is x equal y? I forgot if I used the same example. Okay, this is the second one. Second one. X a equals to y x at the second one. No, this is x. Y. Okay. How to draw? It's very hard. It's very hard. For this, I use different color to explain different value. Okay. Can see first of all, if you need to drive it, maybe you use a longer or shorter arrow. If your number is larger, it's close to yellow. If smaller, use black. Okay, and let's see. Use this picture. Let's see. If you see the plane of x and the y, you see all the arrows are going to positive x if your y is larger than 0. If it is going to negative x, if your y it is minus. See? Okay? Okay. And you will see that when your y is getting larger, your color going to more yellow. This is 0, is nothing, and you have small black, and then getting larger and larger. If your y is getting larger and larger. And then if your y is getting smaller and smaller, of course you have more and more magnitude. Your absolute value of y is getting larger and larger, but your direction is going to different direction. This is when you see the XY plane. It's not your fault, so this is not a test. It's very hard to draw. It's very hard to draw, right? Even I don't know. But if you want to explain this vector very clearly, you need to draw it in at least, I think, 2 planes. If you looking at X and Z plane, you have different value, the uniform value for different y. Y is this direction, right? Okay? Okay. C, we are just looking at a very simple question. Okay. Okay, let's think about it and we take a rest. We take a rest. Then we can continue to have more complicated tasks, and then finally you can answer my question, right? You have an exam, you have activity, you need to write down the question. So now we are good here, and this is a result for x hat, y x hat, and z x hat, right? All of them, you need to have time to write down what and think about what is the variant. Okay? And actually this is a vector A of the unknown x. Maybe you can write. Also you can write down A, but it is okay to write down like this. This means if you change x, your result is changed. And for this part, maybe you can write down like this is y. Okay? Okay? This is unknown. We don't know. This is the position. Then this is unknown. We don't know. Okay? So I think everyone understand for this part, and we can continue. Okay, we have a Chinese. So if you do, this is operator x. Okay. In the vector operation, it is very important to understand the difference between cross and the dot. I know those are the multiplications. If 2 times 2 equals 4, of course, right? But if you write down vectors, if you use A cross B, vector A cross vector B, you need to use this equation. Okay, this is just for your information. Maybe this will not show up very too much, but I just for your information. But one more thing I need to remind you is, how about this dot? If I use A dot B, if A cross B, we will obtain another vector. If A dot B, we will obtain only the scalar. Okay? Have you ever learned this before? No? Yes? You do? Okay, okay, this is a reminder. But the most important thing is that you need to answer a question, so I'm going to tell you the differential operators. Okay. Okay. First, So this is a question. This is shown in your question, right? The gradient. What is gradient? If f is an unknown, scalar unknown, it is a function of x, y, z. You can take a gradient of f. You put a triangle on it. Okay? The equation is you do the partial differential respect to x. Multiply the direction unit vector of x plus y part plus z part. This is the equation. Okay. Did you see the question? Try to answer the question. Try. I think this is the first question, right? The gradient, right? Yes. Question number 1. If I have the function, scalar function f, so what is the gradient f? Try to answer. Choose one. So first question. A, B, C, D. You answer your question and let's check if everyone knows what is it. Okay, try it. This is the definition of gradient. This is very important. So which one? Okay. The first question is, what is your answer? Is your answer vector or scalar? Vector, yes. Very good. Because this is some number multiply vector, some number multiply, some function multiply vector, some function multiply vector. So the result will be a vector. So it's very easy to choose the question, to choose the answer, right? Okay. But your function f is a scalar. So for gradient, let me write down the result, make an organization. So gradient, B-I-E-N-T, okay. Your scalar will become a vector, right? Your answer is a vector, but your question is a scalar. Okay? So which one is the answer? B, right? Everyone go correct for the first question? Okay. How about next? So this is the question. Divergence. Divergence. Different. Divergence. The definition of divergence is if you have an unknown vector, it has a x component, y component, and z component. You use a divergence. Okay, it's different between gradient divergence. Okay, there is a dot between your triangle and your vector. Okay, so it will be the summation of, see, owning the x vector, owning this part. Be careful. Some of you may make mistake. Owning this part, take the partial derivation to the x plus ay divided by y, and also z to z. Okay? So, for the divergence, the next question that you can answer, you change your vector to scalar, right? So they're different. You take a gradient, your scalar become vector. You take a divergence, your vector become scalar. Vector scalar and the gradient scalar vector. Okay, it's reverse, a little bit like a reverse, but it's not direct reverse. Okay, it's not a direct reverse like plus and minus is direct reverse, but this is not direct reverse. It's relevant. It's something very close, but you can think like that. Okay, so you can answer the question number 2, right? Okay. Is that hard? Maybe I will give you some bonus. I will ask you a question in the midterm. Okay. Good. Easy to answer, but you need to understand the scalar and the vector. Okay. For the midterm will be an open book exam. Don't worry about. But you need to know where the question, the definition is. Okay. Okay. For the second, divergence. Okay. Then the third one is the most difficult. Number 3, curl. This is most difficult. Curl. Okay, let's see. Curl is you use this notation, triangle and close. We call this curl. You put a vector A become another vector. Vector become vector, okay? Vector still become another vector. And how do we calculate this one is the most important thing. You need to draw this basket. You need to draw it, okay? X, put the S hat here, Y hat here, and Z hat here. And then you put the operator partial X to X, partial to Y, partial to Z here. You just copy it. Okay? Then you put your question vector AX here, AY here, and AZ here. Okay, this is the first step. Maybe you should do that simultaneously at the same time, and you will understand. Okay, try to do that for maybe the third question. Do I ask a question about curl, right? Try to put the answer. Try to draw this box. Write down this box and put your question inside. Okay. Okay, I will wait. Then you wait for you. Maybe you're too fast. This one you don't need to remember. Even this open book exam, you don't need to remember. You just write down this form. Okay. So put the question of AX, AY, and AZ here. Then try to do something like that. Do this one. This is you put them together. This part. Okay? You put them together like a multiplication. And change the number. And change the color. The blue one and the green one. Okay, this is for write left up to the right down for these three colors. 1, 2, 3 is green, yellow, and the 1, 2, 3 is blue, and the 1, 2, 3 is, the order is not important because you can change it. They are just plus. But for the right side, right up to the left down, you need to put a minus for also the three part of them. So those are the answers. Okay? And you can do some organization. You put all the x unit vector together, y unit vector together, and the z unit vector together. You can have the result. Okay? This is a curl. So for the curl, your question is a vector, and then your answer is also another vector. Okay? One, two, three. Okay, so you can answer my question for question number 1, question number 2, and question number 3. Are we good? Okay.
There are 2 more questions for fun. If everyone finish it, I can continue. Let me check you if everyone can follow. Okay. So still take time, right? Finish? Okay. I think everyone, if you want, you can follow my class, especially at the beginning, right? If you want, but if you have something else, yeah, I think everyone is good. Everyone is good. Okay, you finished? Okay. So then, all of you try to finish the rest, okay? For question number 1 and 2 and then 3, I will make it show in your midterm. Just understand how to do that. You understand what to do. It's just only the first step. You need to practice. You need to practice to check your answer is right. It's very important. Okay? Everyone can get good score. It is because for anyone, if he can get good score, he must practice before he understand, after he understand. Remember our IF class last semester, right? You understand, but you don't know. You didn't get the right score. I cannot give you a point because you didn't practice. You need to check your answer is correct. You need to practice. This is also your responsibility. I already give you the exercise. I think I did more than what I need to do already. But you need to practice. Or you will say, I know how to do that, but I didn't get the right answer. Yeah, you get the same score as you don't understand. So you need to practice. That's important. Okay. No. Do you know this? If A is x hat, y x hat, and z x hat, what is the direction of, or what is the direction of the curl of these 3 3 vector. Let's just see the answer. Okay. So if your A is this one, you take a curl of this, you get nothing. You can do the calculation. Okay. If this one, you take a calculation is minus z, you take a curl. Think about that. Curl is like a function of you turn it, right? And then for zx is this direction. It was this vector will become a new vector, and this is a uniform because you take the partial derivation, right? You take a partial x, y, partial z. For that one, you don't have 0. Okay. Okay. Think about this is your question on the paper. Do you know what is this and what is the curl of this vector? Let's guess, okay? Y times x minus x times y vector. Which one? Put that on your paper.
Do I need to write down? Oh, you have a question on the so you want to check. Which one? Yes.
A, right? Because for everyone is the component of x and the y, a combination of x, y, right? And it will become a circle. Okay, so if you take a curl of that, become, I will guess it is the direction of D.
Because you use your right hand, you put that on the circle with that, and you will know the direction. Curl is very useful when you think about, do you know the Ampere's law? Do you remember Ampere's law? If you have the matter, if you have a current pass through a line,
Do anyone know Ampere's law? Have you ever heard the Ampere定理, right? Ampere's law, right? If you have a current, right, then you have a current is a moving electric charge. Then you will have a magnetic field on it. So you will something looks like that. We will see some nature phenomenon, 现象 nature. Okay, the scientists can observe that. They try to explain what they observed in these notations. Those are the Maxwell's equations. You need to know the vectors. You need to know these operators. Then we can explain what happened for the electromagnetic field. Okay, so this is very basic, very important. There are two more operators because when you are doing the field, the vector, the scalars, then you will have more complicated operators. Okay, try to remember that. It's very similar to these three. We call this Laplacian. Have you ever heard Laplace? Yes, right. Laplacian. Okay. This is the Laplacian of the scalar field. This is the how to do. This is a notation of the Laplacian. It's like a triangle and you put a 2, okay, to the power 2. This is Laplacian, okay. And what is this? It is actually, you use the gradient f and then you do the divergence again, okay. So this is it's not a double gradient because you cannot do a double gradient, right? Why? Do you know why? You cannot take a gradient twice because yes, very good. If you take the scalar, you take a gradient, it becomes vector, right? The vector cannot take a gradient again. So you need to take a divergence. So, okay. So therefore, if you do a Laplacian to do the scalar, what is your result? It is a scalar again. Okay. So let me write down. So Laplacian, C-I-A-N, is you take gradient, then you take the divergence. Okay. So your question is a scalar, then your answer is also a scalar. Okay? Not so hard, it's like a combo. Right, do this and do another. I call that Laplacian. Okay. But the question is not finished yet. You have another. This is a Laplacian for the scalar of a scalar field. You also have a Laplacian of the vector scale, of a vector field. If you took a Laplacian of scalar, you deal with only this scalar function, right? But if you take the Laplacian of the vector field, you should take 3 scalar functions on the vector functions. There are 3 scalars on the vector, right? You took each of them with Laplacian scalar individually. Okay, this is a little bit complicated, especially if I give you a question. And then also you can take A become A. So Laplacian, you can deal with this or this one. If you do the Laplacian to a vector, you do 3 Laplacian of scalar for each direction. Okay? Okay, that's it. In the end of our basic knowledge. Then we can start our class. Those are our extra. I need to tell you this common sense before we start the class. Okay? still need time to think? Okay. So, that's it. And we can start. So now we can start the first class of microwave engineering. After we communicate with those basic knowledges. So for the first part, before our midterm, I'm going to give you more common sense of electromagnetic theory. I know some of you told me that, oh, you don't have a chance to take this class, the EM class, right? So I will try to tell you, I try to make it easier to understand, to put most of the important ideas of the EM class before our midterm. Okay? You don't understand what I'm talking about? I use some Chinese. 你们很多人没有修到电磁学，说没有开，对不对？所以我们期中考前，我在上的东西就是电磁学，这样 ，OK？ 就是我把电磁学浓缩到我讲到的重点，包含刚刚的空间向量，那些东西都是电磁学要上到的部分，这样那些梯度、散度、旋度，还有Laplacian equation， Laplace那个 operators， 这个都是电磁学的这个基础，在讲电场跟磁场之间的关系。OK， so let's continue. So let's start the class. So the part 1 of the chapter 1, the part 1 of chapter 1. See, I told you that before our midterm, I will only teach you chapter 1, right? And I separated the chapter 1 into chapter 1-1 and chapter 1-2. I separate chapter 1 into 2 parts. Alright? And for the part 1 of the chapter 1, I have 4 important terms need to explain. There are 4 important, this is the outline. Yeah, outline, 4 important things you need to tell you. This is the part 1 of the chapter 1, and there are 4 points. Okay. The first, Maxwell's equation. As I said, it's very, very important. Actually, those are the equations, those are the conclusions. Everyone talk about that, everyone use that. You need to understand that very clearly, and we will apply Maxwell equations to many theories in the other parts of this class. Okay. If you want to derive something, you need to have the beginning, right? You need to have something, because you know this one, then have this equation, then you have a next step and another step, right? And usually, Maxwell equations, those are the source, the beginning, okay? The beginning of many theories. So, we need to explain Maxwell's equation at the beginning, then you use the theory to other theories, okay? Maxwell equations. Then after Maxwell equations, we apply Maxwell equations to boundary conditions. This is the first new theory after we know the Maxwell equations. The first, you use this one, then you can obtain this one. And after that, we talk about wave equations. We know electric field and the magnetic fields. Okay. What is the E field? What is the magnetic field? What are they? You need to, I need the equation for that. We need to solve it from Maxwell equations. Okay, so use Maxwell equation to solve this one, to obtain this one. Use Maxwell equation to obtain this one, and obtain. Then you get this easy. The number 4, the fourth part, the plane wave in the lossless media is the result you obtain from the wave equation. Okay, so those are, all of them are important, right? This is a source. This is the beginning. This is the beginning, right? I use a picture to tell you. You have a source. Then you use the source to get this one, and you use the source to get this one. Then you obtain this one. And what is this one? This is the most easiest case of electric field. Why? Why easy? It's the plane wave, and also in the lossless media. Only maybe air or only something very pure. So this is very, very easy case of the field. Okay, so we are talking about EM field. Can we start? Okay, after the outline, we can start. So, what is the first thing we are going to do? We try to talk about Maxwell's equations first. So, Maxwell equations. Maxwell equation. This is Maxwell equations. Okay. Can anyone remember what I told you last week? Can anyone told you? Can anyone remember this one? Or let me repeat again. Okay, this is the most important thing because it's the beginning. The beginning. What is the Maxwell's equation? Let me read. It's the electric and the magnetic phenomena we call a field. Electric and the magnetic. Do you know magnetic? Do you know? Yes, okay. Electric and the magnetic field phenomena means this is the nature. We don't explain why. We measure it, we observe it, we see that, okay? They are happening in this world, nature. This is a phenomenon. Okay, we know this is what happened. At the microscope level, microscope level means, okay, maybe we can measure it. It's a result, and described by the Maxwell equation. They can use the result. See, this is why I told you we need to learn these operators, because if you don't know vectors, you don't know operators, how can I explain everything? Okay. You have the E field, but remember in your poser, your field, the vector, they don't put an arrow. He just used the head, but we are talking about the same thing. Also the vector, okay? He used only a bar, but I am used to use the head. It's because it's vector, but he used its bar. They are the same, okay? So forgive me, we just need to understand that both of them are okay. Okay, you put a bar, you put a head, those are the vector, they are the same. Okay. You take the, what's that? Maybe call someone to answer. Do you want to, what is this operator? Curl, right? If you have a vector of E, E is a field, you take a curl, equals to minus partial differential to T. Oh, It's a function of time, not only space. To B. What's B? I write on this table. See? B is a magnetic flux density. It is also a vector. Okay? B is also a vector. This is a magnet flux density. What does that mean? I think you just remember it. You can see like, let me explain electric flux density first, okay? Electric flux density means there is an area. You have a lot of electric field lines go through the area. That is electric flux density. This is D. Then B, magnetic flux density, is something very close to, very similar to electric flux density, but it is magnetic. Okay. One thing important is maybe you need to think too much about B and D. You can check this one. Use this relationship to understand B and D. Okay? B is H is the magnetic field, right? Multiply mu 0. And D is epsilon 0 multiply E field. Epsilon 0, we will have some chapter talk about epsilon and mu. Have you ever seen this before? For FR4, epsilon R equals to 4.2, right? Everyone, if you design a circuit, you do that, right? Epsilon R. Okay? And epsilon equals to epsilon R times epsilon 0. This is the constant of the air. Epsilon R is 4.2. So the total epsilon is some parameter of the material. And if this is a free space, we are talking about the air. You use epsilon 0. Can you get it? For these two, B and D, you just remember that. Okay. First of all, let me write down first. To explain Maxwell equations, you need to have the beginning, and it will take time to explain, but I have to tell you the result in the beginning. E is the electric field, okay? Everyone heard this before, again and again from me, right? Electric field. And also, you heard H field. This is a magnetic field, okay? Okay. There is an equation. If you multiply E field, if your E field is in the air, usually, very often, right? Your electric field is in the air. You use this parameter, epsilon 0. This is a number, okay? You put a number, remember it is think it's a number. You can, if you have a textbook, then you have a constant like that. Okay, never mind. You multiply this number, this will become D. D is electric flux density. You just multiply some number to a vector and it become another vector. Okay? And this is electric flux density. You use this equation. Okay? You just multiply a constant to your E field, then you obtain another vector. We call that electric flux density. Alright? If your E field is in the air, you use the some number relevant to air. Okay? Then there is another very similar equation you call mu zero multiply your magnetic field will become B. This is the magnetic flux density. Okay, I try to explain because I think most of you heard this too before, right? But you don't hear this very often, right? So try to simplify the equation. D equals to epsilon 0 E, and B equals to mu 0 H. Okay? You just use this relation. So, if you have the same E field, but in different material, you will use different epsilon. Your E field is the same, but the electric flux density in the, maybe in the water, in the glass, in the wall, you will have different D. Even you have the same E field, the same H field. You multiply different material parameters, you obtain another D. Okay? Okay, I think that's okay. 我中文讲这边听得懂吗？这边我要解释 Maxwell equations 嘛？那你们都有听过 E 跟 H 对不对？电场之上应该都有听过，就算你没有做过，你有听过嘛？我们就先假装它是一个向量，就不要管它就是个未知的向量，就这样。那它向量形式就像刚刚写给你们的那些例子是一样，那就没有问题。那问题是 Maxwell equations 里面会有 D 跟 B 这两个东西会出现，它的名字就叫做这个叫做磁通量跟电通。那讲中文你好像有听过对不对？什么磁通量、电通量有吗？我要解释它就是它上面它那个线有几条那个，反正它就是不好解释。啊，公式就很简单，你就看它的材料，它的材料是什么的？它的这个 epsilon 0跟 mu 0，这是叫空气的 epsilon， 然后这个是空气的 mu， 那你就把它乘上，它就是它的 d， 那这是它的 b， 就这样子。我们把事情简化，你不要太复杂，因为后面有想要比较重要讲的事情。反正就是E等于E乘以 epsilon 0等于 d， 然后 H 乘上 mu 0等于 d， 就这样子。如果是在空气中，那今天我跟你说它在不同的材料，就考试的时候我跟你说这不是空气，这是其他的东西，这个数字你就要乘那个东西的数字，就是这样子。这样，那材料这个东西会在刚刚讲的这个4个部分后面再补给你们，因为那个东西也很重要。但是我现在一次要讲它最后的结论，这个 Maxwell equation 这4个方程式的这个结论，我要一个一个讲清楚。你先有这个结论，我们再补上它的解释完，最后再要用。它是我们的微波工程的起点，所有东西都是从刚刚的4条推出来的。那这4条就是你要知道向量，你要知道 gradient divergence curve， 你要知道这个东西，我才有办法解释这4条。那有这4条，你才这4条一直发展出后面的全部的章节出来，这样子，这样 OK 吗？哦，不是故意要搞你们，但就是要从这里开始。好，那这个在这边下课前的话，我们来解嘛，对不对？下课前有一个东西你们注意一下，我写的 BHDE 跟课本上的 BHDE， 你有没有发现写法不同？是不是抄写？抄写表示它是会随时间做改变的。除了 X、Y、Z， 它还有 T， 那4个变数了。我们刚才还没讲到 t， 朝鲜就是有 t， 就这样子。哦，不要怕，就是都要讲。实际上电磁波就是会随之时变嘛。然后你看它的这个拿斯威尔方程式，哦，这些全部都是斜体。你要看还对 t 微分，所以它一定要有 t 的变数才能对 t 微分啊。其实我这样子就已经这4个都解释完，我们等一下再把这4个 source 再解释一下。他在解释了电场、磁场跟那个 source 之间的关系，就是这样。这个是观察到的，自然现象观察到、量到的，看起来很漂亮。电场、磁场是相互，就这么复杂，那种厉害，之前人就可以量到这样子。那我要帮你解释完，我们才有办法开始。你要先知道这个4个。像符号，然后斜体，然后 D 跟 B 解释完了，再来就只剩这 MJ Zoe， 这样就知道是这4个关系。休息一下，脑力快用完了啊。Okay, let's finish the explain of Maxwell's equation. There are 4 equations for the Maxwell equations. The first equation, you take the curl to electric field equals to the magnetic flux density. Take a partial differential to the time, and I get a minus sign. Minus m. What is m? For these 3 notations, those are source. These 3, m, j, and the vo, they are all source. And for the other parts, those are the field, E field or H field or the flux density. Okay? Okay. What is M? M is magnetic current density. Magnetic current density. And J is electric current density. Okay, let's look at the unit. If you took my class last semester, you remember that one of the important things you need to write down on your answer is unit, right? Remember, all units are one point. Remember that for the 射频无线通讯系统 unit is very important. You need to use the unit to understand what is it. For the E field, it's voltage over meter. For the magnetic field, the unit is ampere over meter. See? Electric fields is relevant to the voltage, and the magnetic field is relevant to the current. It's ampere, right? It's volt, ampere, over meter. Okay. And the D, the electric flux density, is a unit is curl over M. This is why is curl? Curl is the charge, the unit of the charge, coulomb, curl. Curl. How many electric charge? Coulomb over the area, meter square. Okay? So this is electric, something relevant to electric. And for the magnetic flux density, the unit is Webb over m squared. So Webb is more, we are not very familiar with that, but you just remember it is something relevant to the magnetic. Okay, another definition. Maybe it is you can think like maybe it's relevant to the magnetic charge. Because this is electric charge, right? curl is the electric charge. So WB is relevant to a magnetic charge. Maybe. They are sometimes very similar. E and H, they are some, like voltage and current, they are sometimes very similar. E and H is relevant to voltage and current. Okay? So, except these four, those are about the field. These three, they are relevant to the source. For the first one, M is the magnetic current density. Is volt over M squared is magnetic current density. And the electric current density is ampere over M squared. See? Again, but this is M squared, this current density. Those are the source from the source. And what is low? Low is the curl over M cubed. So how many charges in this volume? This is the charge density. These three are how many sources on some area, on the unit area, or some, what is the source over the volume. Okay, so you can, so far now you can understand what they are. You can simply understand what they are talking about. You take the curl E equals to this one minus something. Remember, let's go back to what I read down here. You take a vector, you curl a vector will equal a vector. You curl a vector, you obtain vector. You take a divergence to a vector, you obtain a scalar, right? Though is only a scalar, this is not vector, okay? You take a divergence B, the vector equals to 0 is a scalar as well, okay? Those are the equations we call, this is one of the very important things, you try to remember, very important. Differential form. Differential form, because you take a differential. Okay, remember that these four are the differential form first and of the time varying Maxwell equation. You have some special character for this notation. Those are time varying. You have a time component on that. This is very important. Remember this, please. This is very important. This is the name of these four Maxwell equations. This Maxwell. There are many different sets of Maxwell equations. This set is differential form, time varying. Can anyone know what's differential form? Anyone help in Chinese? Differential? You don't know? 微分 Okay. 微分形式的时变的 Maxwell equation. Okay, so this is not only one Maxwell equation. This is a differential form, time varying Maxwell equations. Because you see, time are the unknowns. For all the vectors, time may be changed. Okay, so we start here. And this, we already explained this one, right? Except we use the mu and mu 0 and epsilon 0. It's very hard to pronounce it. Let's try to do it. Epsilon 0, we call it permittivity. Try it. Permittivity, yeah, permittivity. And mu 0 is permeability. Permeability, mu 0, epsilon. Permittivity. This is the epsilon. Maybe if this is air, you use the number they have different units. Okay. You need to pay attention on the unit. Those are very, very important. Units are always very important. Okay. So this is a free space, or do you know free space? Maybe perfect vacuum, it's called perfect free space. If you want to calculate the most simple equations for electric field and electric field, we think about maybe air or vacuum, because the most easy way to. The first way is like the beginning. Clean, you don't have something in there. Okay. So those are numbers. It's for the test. It's an open book test. But you should know where you can find these two numbers, right? Do you have a textbook? There, I think appendix A, you have those constant, important constant. If you see the appendix maybe A, can anyone check for that?
我是自己抄的。
它后面有 constant 在最后 appendix 有一大堆，你直接可以看。Because this is an open book test, if you don't have book, you have a book, you borrow book, you should have something. You have these numbers, you need to know where you can find those numbers. Do you see this appendix A? So, C, no? Oh, F, right, see? Appendix F. CF, you can see those numbers, permeability and the permittivity. Epsilon 0 and the mu 0. Okay. In the test, I won't give you because it's an open book. You need to check by yourself and put the number in and give me the answer. Okay, those are, you will use this a lot. That's why I tell you. I try to remind you, you will use this a lot if you want to calculate something. You have the air. Okay. Okay. So let's do the first derivation. Okay. Let's try to do our first derivation. In your, there's some equation in your appendix as well. You can see there is a divergence theorem. Okay, you can check later. Okay, if you have a vector A, you take a divergence, and you take a volume integration, 体积分 volume integration to this is a scalar, right? And you take this scalar to a volume integration, will equals to your vector take this is the circle integration, is a 这个叫做环的线积分，叫 loop integration, line integration, and it is a closed loop integration to unit S vector. This is a theorem, so you just follow the rule. Okay? Okay. If you have A, you do this one. And what we are going to do, the first part is for the number 3 equation for Maxwell equation, and the number 4, this is the Maxwell equation, right? Remember, right? And the Maxwell equation number 4, the small one, 3 and 4. You take a volume integration to this one, and will become another one. Let's try to do that. So this is these two. You use this theorem to these two equations. Okay? So what can we do? This one, if you take this one to volume integration, will become this one. For the divergence theory, you obtain this one for the left part, right? And if you take a volume integration to rho, because rho is current, the charge density. So you take a current, you take a volume integration to the rho is Q. Therefore, you obtain this part, and this part will equals to Q. Okay? Can you follow? This part will equals to Q. Do you want me to do that again? If you, this is, we already knew this is a Maxwell equation if you assume that is true. And we apply the divergence theorem. We use this equation. And we take, if this is this divergence vector equals to some scalar, we take this one, we take a integration, a volume integration for the left part and also to the right part. For the left part, because this one will become this equation, you will vector, you take a circle integration, circular integration, your loop circle integration to your S. And will equals to, because this is current density, charge density, volume charge density, integrated by your volume will become the total charge. So this part will be this part. Okay, and this is not circle. This is a closed. This is a closed surface. Surface. Yeah, I made a mistake. This is this S is a surface, and this means it's a closed. This is a volume. You take a volume. Okay. So what we are talking about is there is a something. Let me find something. You have this one something. If there have we have some charge inside this box, okay? The total value of the charge divided by the total volume, the average volume, it is a charge density, right? Okay, and for this one, we have, this is the surface, because of this equation, you can take integration of the volume, you can see this is the surface. I made a mistake, this is not a circle, it's a surface. This is the surface of this, all the, this box. 我用中文讲也是好的，好吧？它就是3D 跟2D 的概念。好，当我在讲体积的时候，因为它这边会用到它的总体积嘛，积分总体积。那积分总体积它就是一个三维的，它就是 m 的 square。如果是它一个平均的体积的话 ，m square 是整个。 那这个东西会跟它的这个，你看左边是对体积做积分，对不对？那右边这个是什么？这个是 S 是面积 ，S surface 面积。那它这个圈圈代表是一个封闭的面积，整个面积是封闭的。这样子，那这个就只是一个 equation， 说它会有这个。那我们从这个，我们把它转换成，你就会得到这个结果。我们本来的 Maxwell equation 如果它是对的话，我们把它转换为用这个公式的话，它可以得到的最后结果是这个框框会等于 Q。这个框框等于 Q 的推导应该不难，对不对？你只是把它带进去嘛，对不对？那这个东西代表什么？代表说，我这个方块里面它有多少的 charge， 跟我这边里面的电通量对于我这整个面积的封闭面积做积分是会相等的。这个就是电磁学要讲的其中一个。那这个东西就是什么？ This is Gauss's law, if you ever heard that. If you have some charge in a space, you integrate the closed loop of all the area, the surface of the area. The answer is the charge inside this area. This is Gauss's. You ever heard that this before, right? The charge. Okay, so I'm trying to do what we are trying to do is prove that Gauss's law is we observe and the result, right? The Maxwell equation is I tell you, oh, this is true. Actually, they are the same thing. The third equation, this equation is actually the Gauss's law. And this equation is another Gauss's law, but this is for the magnetic charge density. Because we don't have magnetic charge, so we have the result 0. 这样子 ，OK。我最后再用中文再讲一下好不好？今天先这样子。我最后再用这个讲，我觉得。